Hi, my name is Guang, 12 years old. For this lesson, we'll be continuing on with the methods of limit calculation. Over here, we have an example where we have to show that the integral from 0 to x squared dx is equals to 1/3 of x cubed by limit definition of definite integral. So first of all, what we have over here will be, so we'll first be drawing out this graph. So we'll only be drawing the positive side of it because it's from 0 to x. So what we'll be having over here will be, so x squared will somewhat look like this, so y equals to x squared over here. And then after that, we'll also have, since our range is 0 to x, we also have our boundary. Whereas over here, this whole length will be x, okay? So, but I'm gonna name this k because that despite the fact that this whole thing will be having it as x, we'll be calling this point as k because and we'll be separating this length x to k parts. So over here for this part, and on this length of x, when we separate it into k parts, we can have another two random parts, whereas two random lines, because that k being the number of strips that are within this boundary. Here over here, for example, 100 or even more than that. Here you have like a point over here that's I, and then here you have a point that is I plus 1, and those are the 2 points for within the k parts which we'll have over here. Like this, okay? So over here, now that we have gotten this part, what we'll be having over here will be, so over here for this part, in order to find this, what we'll need to do is to have a lot of the strips together, right? So over here, we'll be calculating these strips, by the way. For this part, this is point I, but the length from 0 to point I is xi, while the length from 0 to point I plus 1 is xi plus 1. Just like how this point k, the total length is basically xk, which is basically x. Okay. So what we'll be having here will be, so we're calculating it as a rectangle. So it's your choice whether to look at the left side, where we'll be calculating this height, or we'll be looking at the right side, which will be calculating this height. But still, either ways, when you calculate it, you'll realize that at this rectangle and the actual value, there's going to be error, okay? And how do we deal with the error? I'll explain later. So what about the width and also, right now we are not bothering much about the error. But over here, what we'll be having will be, this is delta x. Delta x is the width, basically xi plus 1 minus xi. And then here we'll have, so it's basically x over k, because the k parts and the difference between these two is basically one of its parts. And now over here we can also find its area for one small strip, okay? So over here, what we'll be having for this part, we'll be having, so for this part, we have our x over k, a bracket square, and then we also have our I plus 1 bracket square, and then we also have our our base, which is x over k over here, which will end up with x cubed over k cubed, and then I plus 1 bracket square. Whereas for this part, now that you have gotten this, how are you supposed to find the total area? So the area, what we're going to do is that we're going to use sigma, so sigma notation, and then so this I have a range, right? So this I can be anything from 0 to k. And okay, so you can look at the left side or the right side. I'm looking at the right side, that's why it's I plus 1. So over here, what we'll be having for this part is, so here you have our x cubed over k cubed, and then x plus 1 bracket squared. So for this sigma, it basically relates to our integral, but during this integral it is continuous, right? While on the other hand, for sigma notation, it is discrete. Okay. So now that you have gotten this, we are going to use a formula to calculate this part, and we are going to have x cubed over k cubed. And then here you have our over 6, and then we'll have the n times n plus 1 times 2n plus 1, which in this case will be k plus 1 times k plus 2 times 2k plus 3. Okay, so over here for this part, why we get this part is mainly because of the so this is in discrete form, and in order for it to be continuous, you have to add a limit. And just in case you don't know, we are basically applying the Riemann's formula, whereas we have a to b, and then we have our f(x) dx, which is equal to limit, and then after that we have our sigma. Whereas in this case, we already have our sigma for this part, and that's what we're doing next for the limit. And then this part over here serves as the fx, while this part over here serves as the dx, while the range is basically what's written here. And to make it continuous, we have the limit. So we'll be having, so over here, I'm just gonna quickly just erase this part. So because we're going to have a k approaches to infinity, so I'm just gonna quickly change this to a x. So k approaches to infinity, and then x cubed over 6 has nothing to do with it, so we can take it out. Then here we have x cubed, and then we have k plus 1, k plus 2, and 2k plus 3. And here we have our indeterminable form of infinity over infinity. So how are we supposed to solve it now? We can use a method of changing conversion between infinity calculation to infinitesimal calculation, whereas both sides just divide by 3 cubed, and then here you end up with 1 plus 1 over k, 1 plus 2 over k, and 2 plus 3 over k. And what you're going to get here would basically be x cubed over 6. Then after here, when you sub it in, the fractions will just become 0, and it will become 1 times 2. And here you can simplify, and you get 1 over 3x cubed, and this is the result that we get, and it is shown. So over here, what we basically did to prove this, that these two are equal, is that wait, give me one sec. And then this is equal. So over here, this is equals to integral from 0 to x squared dx. So these two are basically equal. Okay. So because that we use the Riemann's formula, so the integral over here by applying the formula, how we'll end up with the limit and the sigma, and that's how we get our results. So here you can take a quick look. So what we mainly did was, so for this part we just assumed each of these as strips, whereas we had this length of this x and we separated it into k number of parts, and then this part over here for the k number of parts, as we can take out two of its points, which is I and I plus 1, and then here we have one of its strips, whereas the base will be this part, basically just each unit. Then after that, over here we have our area for each of the strip, whereas over here I told you already where it will serve as the fx for the Riemann's formula. And then after that, over here for this part, you have the sigma, and so the sigma causes it to give the full area and all, but it is discrete and not continuous, and in order to make it continuous, as we will also have to add our limit, and thus over here we get this result, which is basically equals to what we have over here, because then we use the Riemann's formula. So that will be all for this lesson over here. So last but not least, thank you for your watching.